Alrighty, welcome back, Algebra 2 folks. I'm Mr. Chang back here with Mr. Chu again. Mr. Chu, how are you doing today?
Oh, I'm doing terrific. Yeah, terrific.
Excellent, excellent. So our plan today is to introduce chapter 2, which is all about these things called relations and functions. And we're just going to take a quick walk through maybe memory lane, if you remember from Algebra 1, about the graphs of these things. Okay, so we're going to start off thinking back to what we talked about equations last week. And just a reminder here of what a solution to an equation is. Remember, folks, that a solution to an equation is just the set of values for the variables that make the equation true. And paying attention to kind of what I just said there and what's here on the screen, you see that the value or values, plural or singular, for the variable or variables, right? And the reason we bring this up is because last week we had talked about and worked with single variable equations. All there was x. But now we have equations with x and y. Example. Alrighty, so let's take a look at this equation. Y equals 2x squared. Now, Mr. Chu, can you help us find a couple of solutions to this?
Okay, so you want some x's and y's that satisfy the equation.
Yeah.
So I'm gonna of course pick the easiest ones because yeah, least effort is best. Okay,
Yeah, why
so
make it hard when it doesn't
I'm
have to
gonna
be?
pick x equals 0.
Okay.
So if x is 0, that means that y is also 0, right? 2 times 0 is
Yes, and we could just double check this here. Oopsies, sorry about that. We can just check right here. Check. Oop. 0 for y equals 2 times 0 squared. I believe that is totally going to work.
all right.
Alrighty.
I'm gonna pick another so-called easy value. So I think that x equals 1 will give us a easy number. So if that's 2 times 1 squared, so y is 2.
So let's see, that'll be when I plug in x equals 1 squared. So I think, yeah, the y would be 2. That'll work.
All right. I guess for the sake of also using a negative number, I'm gonna use x equals -1.
Oh, clever. Okay.
Yeah. So yeah, clever. We plug that in. So yeah, -1 squared is also 1. So 1 times 2, that's still y is equal to 2.
Yeah, that one's still going to be 2. Cool. So here's a couple solutions. And we might notice like you pick 3 randomly, 0, 1, and -1. But there's got to be more, right?
I think there's probably a few more. Yes.
There's probably at least quite a few more. So the question is, folks, well, if I was writing out my solution set, we could write them out as coordinate pairs. You remember? So 0, again, representing for x, and 0 for y. That is a solution. I can write down 1, comma 2, and so on. But since there's so many, this list, well, you're going to be here a long time if we were to write out that entire solution set. So it's probably easier if we can maybe show it a different way. Here's what graphs are for. They're just visual representations of our solution set. And so that's all a graph is, really. A visual representation of the solution set of an equation. That's what we're going to focus on today. But we'll also see inequalities in the future. All righty. Mr. Chu, you want to help us out with how we set up these graphs of relations? What do I draw? How do I start?
Yeah. Okay. So you're gonna draw two axes, right? So you'll start with your x axis.
Oh, sorry. I tend to start with my vertical.
Yeah. X axes like this.
Going horizontally.
Y axes like that. And yeah, label them x and y. And that's kind of it, right? Then you got to also label your axes so we know some units. So maybe I don't know,
so
1, 2, 3, 4 type deal.
We'll plug in 1, 2, 3, and 4. Sorry about that. 1 and 2, and I guess 3 up here. But yeah. So by convention, folks, we just tend to put our x, which is also called our independent variable. And once we start using these relations to what we call model or represent real situations, it'll make more sense as to why one is called the independent and the other one is called the dependent. Similar to how a parent would be considered independent, but the child is the dependent, in case you've ever heard that term. Yeah, so essentially when we now take our solution set.
Yeah, I think sometimes I say that the value of y depends on the value of x, right? But yeah. Anyways, yeah, okay, go ahead.
Yeah, for sure. That's usually what we think of, especially when we think about functions as function machines. But we will, again, get into that a little bit more later. So I'm going to take some of our solutions that we found previously, along with Mr. Chu's help. So I'm going to plug in, oops, sorry about that, 0, 0, 1, 2, and then -1, 2. So I'm going to have to mark off my negative x values. And so it's the point 0, 0 here, 0 for x and 0 for y. Likewise, when I plug in 1, 2, I'll be at x equals 1, that's right here, and y equals 2, which will be up there. And likewise for -1, 2. As I said before, there's a bunch of solutions, actually, in this case, infinitely many. And so the way this graph would work, or would end up looking like, would be something like this. Don't worry if you don't quite remember why the graph looks this way. And this would go on forever. But we're going to take a look at, again, different types of equations and why their graphs look the way they look. Okay. And so just a little more vocabulary, folks. Mr. Chu, you want to help us out with what our domain and range mean?
Well, let's see. Oh, you want me to just read it, I guess? I mean, it's right there, right? Okay. The domain is a set of values for the independent variable, usually x, and the range is a set of values for the dependent variable, usually y.
Mm-hmm. And so we can see, given the graph, you can actually determine what the domain and range are. Mr. Chu, how are we doing on time? Do we have time for an example?
We're at like about almost 7 minutes, so maybe we should kind of wrap it up.
All right, so in the next video, folks, we're going to take a look at some funky looking graphs, hopefully, and we're going to take a look at how you can look at those graphs and just pick out their domain and range.
Hey, one question before we end. I have a
yes.
question about like graphing.
Mm-hmm.
Like, how do I know, like, if I'm graphing this function that you gave me, we picked 3 points.
Mm-hmm.
Is 3 points enough? How do we know, like, how many points should we pick to make a graph?
Really good point, Mr. Chu. So I'm going to actually copy this back over here. So I'm just going to take a quick second and sketch these points again. So let's see. There's there. And so let's see, we've had, let me label these. 1, -1, 1, and 2 here. And so, yeah, you're absolutely right in that we actually don't know what's going on between, like for x values between 0 and 1. What happens down here without actually checking? And so we really would need to, technically speaking, we would need to plug in, like right here, x equals 0.1, and then right here, x equals 0.2, and so on and so on. But as we get towards investigating our different types of functions, linear functions, quadratics, and so on, we'll kind of notice their patterns, and we'll have a good, what's the word I'm looking for? We'll get some better intuition as to how the graph should behave.
Yeah. Okay. So kind of like if you're not sure what it looks like, you might have to graph some more points.
Absolutely.
Unless
right.
unless you have some knowledge, then you could graph fewer points. Okay. All right.
Right.
I think that's good. Thank you.
Yeah. Thanks, Mr. Chu. We'll see you
All
in the
right.
next one, folks.
Okay.